What's up, everybody? This is Daniel Mathematics here with another example to explore, guys. And today, guys, I want to go over example 7 and example 8 real quick on how to solve inequalities with variables on both sides, or inequalities that have multi-steps to them, right? Now, remember, guys, an inequality is just basically proving the potential values of the variable, right? Basically, it's saying that, okay, the variable, the potential values of the variable could either be greater than or less than this, or greater than or equal to this, or less than or equal to that, right? So that's what we're doing, guys. That's basically inequalities, right? That's the difference between an inequality and an equation. An equation shows what the variable actually equals, the one value that the variable equals, when inequalities give us an array of values that the variable or the unknown value can equal, okay? So I just wanted to just point that out, guys. So in example 7, once again, we're gonna follow these same steps as we've been following, guys. In example 7, guys, I have 28 plus 8x is greater than, greater than, right? When it comes to inequality, guys, I look at them as Pac-Man, okay? And think about Pac-Man, guys. If you pay Pac-Man, and you from my era, I know for a fact you did pay Pac-Man, right? You know that Pac-Man is always gonna go in the direction where there is more food, right? It's always gonna do in a direction where there's more food or there's greater. Right? So if the mouth is facing a certain way, it's saying that that particular side is greater than the other side, okay? So it says 28 plus 8x is greater than, I just want to put that, guys, greater than the opposite side, which is 4 plus 5 times a parentheses 3x plus 2 parentheses close, okay? So before we even start off with the usual first step, which is combining like terms, I see, guys, that I need to distribute right here, all right? This 3x plus 2 inside of the parentheses and this 5 on the outside of the parentheses lets me know that I have 5 of these, okay? But instead of me adding this 5 times, I can just multiply it by 5, okay? So that's what I'm gonna do, guys. I'm gonna multiply this whole inside of this parentheses by 5 to get the true values that are within the parentheses, right? Or the true expression, rather. All right, so let me go ahead and do that. Let me draw the line going through my inequality sign. We gotta do that for sure. So let me go ahead and distribute. I have 5 times 3x. Okay, 5 times 3x is 15x. So I'm gonna start rewriting everything. Okay, I still have that 4 in the front, so I'm gonna put 4 plus, once again, 5 times 3x is 15x. 15x. And then 5 times 2 is 10. 5 times 2 is 10, okay? So now, guys, the right side is gonna read 4 plus 15x plus 10. That's what you should have. If you're doing this problem with me, that's what you should have, all right? So then, and then on the left side, everything else comes down the same. And then now, guys, we're able to combine like terms if needed, okay? So let's go ahead and do that real quick. Okay, so now we're actually gonna start step 1, which is combine like terms. On the left side, guys, I cannot combine 28 and 8x. I cannot combine those because those are not like terms, all right? But on the right side, guys, I can combine 4 and 10 because they're both singles or constants or however you want to say. They're both just numbers, right? So 4 plus 10 is 14. So 4 and 10 combined together will equal 14. So now I'm going to rewrite everything. Now I have 28 plus 8x is still greater than 15x plus 14. Okay? Now, remember, guys, remember my labels, guys. Whenever you see a coefficient and a variable, they're being multiplied together or they're in operation with one another, I call that a relationship. Whenever you just see a number that's not attached to a variable, I just call that a single number, okay? So that's how we label, and then from our labeling, we're gonna be able to label each side, okay? So we can end up going to step 3, which is moving values to the correct side. So 28 is not attached or is not in operation with x, so that's an S. 8 is being multiplied by x, so that is a relationship or operation. All right, 15 is being multiplied with x, so I'm going to put a heart because they're in operation with one another. They're multiplying one another, right? And then 14 is just a single number, so I'm going to put S for single. All right? Once again, guys, in all my other videos, it doesn't matter what side you label as the relationship side and the single side. I will always prefer to label the relationship side, where x is in a relationship or in operation with the higher coefficient. 15 is greater than 8, so I would prefer for us to label this side as the relationship side, just so we don't deal with negatives. Because if you label the other side as the relationship side, right, you're going to be dealing with a lot of negatives. All right, so that's the reason why I choose it to do that way, right? But either way works. Whatever way you want to do it, it's cool, right? So this side is the single side, and this side is going to be the relationship side. So that's why I have those symbols at the top. And then now, guys, all we have to do is do step 3. Move the values on their correct sides by matching the symbols, right? If the symbol match, the value stays. If the symbol does not match, the value needs to move, okay? So let's go ahead and do that. All right, let's go ahead and do that. 28 is a single and it's on the single side, so it stays. 8x is in a relationship and it's on the single side, so it needs to move over here with 15x on the relationship side. The opposite of saying plus 8x is minus 8x. All right, so 8x minus 8x cancels out, and then I'm going to subtract 8x from 15x. Okay, cool. All right, 14. 14 is a single and it's on the relationship side. It needs to move over here with 28, right? But the opposite of saying plus 14 or positive 14 is negative 14. That is the opposite or the inverse, all right? So I got to subtract 14 on both sides from like term. And then 14 minus 14 cancels out. So now, guys, I only have these two operations on each side, right? I have 28 minus 14, which is 14. And I have 15x minus 15x minus 8x, my bad. 15x minus 8x, which is 7x. I was already thinking about the answer. All right, 15x minus 8x is 7x. So now, guys, you should have 14 is greater than 7x, right? 14 is greater than 7x. So then we're going to do the last step, guys, which is divide the coefficient away from the variable, which is breaking up. So I'm going to divide 7 away from x, and I'm going to divide 7 from 14 to get the potential values of x, right? All right, so 14 divided, I should have never did that little slash, right? So 14 divided by 7 is 2. 14 divided by 7 is 2, so I'm going to do this because I'm going to have that much space. Right? So 14 divided by 7 is 2. So now, guys, our answer is 2 is greater than x. Or, right, you can flip everything and you can say x is less than 2. Okay, either or is the correct answer. It's basically saying the same thing. It's saying the exact same thing. It's just rewritten differently. It's written differently. So you can either say 2 is greater than x or x is less than 2. I always prefer to always start with x, okay? Because that's what we're comparing. We're comparing the value, the potential value of x to the number that we're comparing to, right? So with x has to be less than 2, that means that the potential values of x could be any number that's less than 2. It could be 1, it could be 0, it could be -1, it could be -2, and so forth and so on, right? So once again, x could be any number that's less than 2. And these are some of the potential values that x could possibly be, okay? So that's how we complete example 7. Now we're gonna go on and go to example 8. Let's go ahead and do that real quick, guys. I don't have to distribute, as I can see. So I can see that I can go straight into step 1, which is combine like terms, okay? So once again, I have -6n minus 4n is greater than or equal to 6 plus 1 minus 7n minus 1. So let me go ahead and draw that line to divide the both sides. All right, and then now we're gonna do step 1, which is combine like terms. We're gonna do step 1, which is combine like terms. okay? I can combine negative 6n with negative 4n, right? If I have two negative values, just add them like positives, but keep the negative sign. Negative 6 plus a negative 4 is a negative 10. So that would be a negative 10n. All right, so now I have negative 10n is greater than or equal to, and then now we're gonna do the opposite side, guys, okay? I can combine 6 with a positive 1 and a negative 1, okay? A positive 1 and a negative 1 cancels out. So now I just have 6. So it's gonna turn into 6 minus 7n. Or I could have did 6 plus 1, which is 7, minus 1, which is 6. However you wanted to do it, it was gonna be the same. So 6 minus 7n. Now, guys, we're good. We have combined all like terms, and now we can go to step 2, which is label each value, and then we're gonna label each side, all right? So once again, guys, negative 10 is in an operation with n, which is saying negative 10 times n, so I'm gonna put a heart, meaning they're in a relationship, all right? Because they're in operation with one another, right? 6 is not attached to a variable or n, right? So I'm gonna put an S. But negative 7 is being multiplied by n, so they're in operation with one another or a relationship, all right? Cool. Now you remember, guys, the side that you want to pick, right, is the side where x, or not x, n in this particular case, is in operation with the greater coefficient. Negative 7 is actually greater than negative 10, right? When you look at negative numbers, the bigger the number appears, actually the smaller it is. The smaller it appears, the bigger the number, or the greater the value is, right? So negative 7 actually has a greater value than negative 10. So let's go ahead and label this side as the relationship side, right? And then the left side as the single side, all right? What we're going to do is, and you know what, guys? What we're gonna do is we're gonna do it the other way. Let's just act like we didn't do the whole coefficient thing, so I can show you if you don't do it this particular way, then you're gonna be dealing with negatives and you're gonna have to do this extra step. So let's just go ahead and do that, guys. So I can just teach this one particular part. So let's just say that you didn't do all that. You just automatically say that this side is gonna be the relationship side, and then this side is gonna be the single side. Let's just do that, all right? So negative 10 and n are both in the relationships, and they're on the relationship side. They're good, all right? 6 is on the single side. They're good. But negative 7n is in a relationship and it's on the single side, right? So what we need to do is we need to move negative 7n to the opposite side where it needs to go. So the inverse or the opposite of saying minus 7n or negative 7n is positive 7n or plus 7n. All right, so let me move on this side. So let me put plus 7n. All right. And a negative 7n and a positive 7n cancels out. Then I have negative 10n plus 7n, right? Cool. All right, negative 10 plus a 7n is negative 3n, all right? If you have a calculator, you'll find out that that's negative 3, which is negative 3n, right, in this particular case. All right, so I'm gonna put negative 3 n is greater than or equal to 6, okay? Now we down to the last step, guys, which is to divide the coefficient away from the variable, which is breaking up, right? So I'm gonna divide negative 3 away from n, and I'm gonna divide negative 3 away from 6, right? So negative 3, n divided by negative 3 is just n, and then 6 divided by negative 3 is actually a negative 2. Now, ladies and gentlemen, this is very, very important. Because we had to divide by a negative, so I'm gonna put that, divide by negative coefficient. Whenever you divide by a negative coefficient, guys, the inequality sign has to flip, okay? The inequality sign has to flip. So let me put that, guys. Inequality sign must flip. All right, so we're gonna have to actually flip this inequality sign. So now it's gonna be n is less than. So now the sign is flipped. So now it's less than or equal to, and then 6 divided by -3 is a -2. 6 divided by -3 is a -2. All right, so x can be any value, right, that's less than or equal to -2, okay? So, and when I said x, I meant n, right, which is the same thing, right? So n, guys, can actually be -2, right? Or it could be any number that's less than -2. So it could be -3, it could be -4, it could be -1000, whatever number that's less than -2 or equal to -2, right? N can be, okay? So once again, guys, that's example 7 and example 8 of how to solve inequalities that have variables on both sides and inequalities that have multi-steps, okay? So thank you so much, guys, for tuning in. Talk to you next time.